Hello students, let us start next video of set theory for class 11. But before starting this, we take the brief revision of the first video that we did yesterday. So please concentrate on this. First of all, we did definition of a set. A set is defined as the collection of well-defined different objects. A set is denoted by capital letter of English alphabet. For example, first students in a class is a set. Why? Because it is well defined. We know that how many students are there and which students are there. Second, the collection of wise persons in a country is not a set, as the word wise is not well defined. So this is not a set because the wise wisdom level differs from person to person. So we cannot define it properly. That's why it is not well defined. If a set P contains an element C, then we write it as C belongs to set P and is written as C belongs to P. Elements of a set, the members in the set are called elements of the set. Representation of a set can be represented in two different ways. First is the roster method or tabular method. In this method, all the elements are listed in curly brackets separated by commas. For example, A is equal to curly bracket 2, 4, 6, 8 bracket close is the roster form. Why? Because we have enlisted elements 2, 4, 6, 8 in curly brackets and they are separated by commas. Second, B, set B 1, 3, 5, 7, so on is the roster method. Again, these elements has been enclosed in curly brackets. Second is the set builder method. In this method, a set is represented by stating all the properties which are satisfied by the elements of the set and not by any other element outside the set. So in this case, when we write the elements of a set that are written with the help of properties, common property of that element. For example, first is A set P is equal to X such that X is a vowel of English alphabet. It is very clear that X is a vowel. Vowel is the common property. And the elements are, as we note, that A, E, I, O, U. Similarly, B, X such that X is a natural number. These are examples of set builder method. Natural number. It's a common for all these 1, 2, 3, 4, 5, 6, so on. So then we take finite set. A set is said to be finite if it contains a finite number of elements. That is, these numbers should be countable. For example, set A is equal to 1, 2, 5, 7, 8, 9 is a finite set. Why? Because it has 6 elements. We can count these. So that's why they are finite, so it's a finite set. Then infinite set is set which contains infinite number of elements is called an infinite set, which are uncountable. If a set contains uncountable that cannot be counted, then that is an infinite set. For example, B such that X, B, X such that X is a natural number is an infinite set. Now, natural numbers, they are which are 1, 2, 3, 4, 5, so on up to infinity. So we cannot count these are uncountable. That's why we call it as infinite set. So this is what we did in the first video. Now we are continuing set theory in the next video. Set theory for class 11. Then we take the other types. First is the null set. Or empty set. Or void set. A set which has no element is called a null set or empty set. So we can write a set which has no element is called a null set. A null set is written as thus just curly brackets, there's no invalid, or we can denote it by the letter phi. For example, the set P is equal to this is a null set. Why? As it has no element. It has no element. Therefore, number of elements in set P is 0. The next is the Singleton set. Singleton set. As clear from this name, any set which contains a single element, one element, that is called a Singleton set. We can write a set which contains a single element is called a Singleton set. For example, Q is equal to 7 is a Singleton set as set Q has only one element 7. Only one element 7. Therefore, number of elements in Q is 1. Next is equivalent sets. Equivalent sets. Two sets P and Q are said to be equivalent. Said to be equivalent sets if number of elements in P is equal to number of elements in Q. For example, if P is equal to 1, 2, 5, 6, Q is equal to A, E, G, H, then number of elements in P is 4, number of elements in Q is 4, therefore number of elements on P is equal to number of elements in Q, which implies that P and Q are equivalent sets. Then we take equal sets. Two sets L and M are said to be equal, if L and M have same elements and it is written as L is equal to M. For example, let L is equal to PQRS, M is equal to PQRS, then set L is equal to set M. Unequal sets. If two sets X and Y have different elements, then they are called unequal sets and it is written as X is not equal to Y. Next is subsets. A set P is said to be a subset of Q if every element of P is in set Q. It is written as means P is a subset of Q, which implies P is a subset of Q if Y belongs to P implies Y belongs to Q. For example, if P is equal to 1, 3, 5, 6, 7, 9, Q is 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9, 10, then P is a subset of Q as all the elements of P are in set Q. Thank you. That's all. Rest we shall continue in the next video. Thank you very much.